All right, hello everybody. Welcome to the April meeting for the Policy Simulation Library Meetup. As usual, I am Anderson Fraley. I'll be hosting for the afternoon. If you still haven't grabbed some Chick-fil-A, there's still a little bit left in the back, but let's go ahead and get started. So first up, we do have a couple of updates from some projects we've been watching in the meetups. So first we have Kevin Parise from the CBO to give some updates on the work that they're doing. And after him, we'll have Weifeng Zhang doing an update for the Policy Change Index. So, Kevin, come on.
Thanks, Anderson. I just want to briefly mention four products about our new version of our health simulation model. The items that have been released that are worth exploring if you're interested in this type of stuff, which I think most of you probably are, is a high-level slide deck that goes over kind of the architecture of the model and presents some background on what the major components of the model are. The second release in this product is a bunch of code segments for the model that kind of goes into a little bit of the details under the hood. The model is written in SAS, so the code is that's up there is I think there are 6 separate SAS programs that are part of the model, and then a data dictionary as well that goes along with it. And then there's a detailed working paper that was released all at once with a lot of description about the data preparation. The model uses the CPS and then aligns to a bunch of other administrative targets and goes through all of the data sources and the ways that the model pulls those together. And then finally, there's a short report that's kind of at a more high level that gives you an overview of the model. The other 2 items that I wanted to highlight for you are Social Security related, and they come out of our long-term modeling unit and are based off of our model called CBOLT, the CBO's long-term model. And the first one is on replacement rates for long-term workers, or not just for long-term workers, I'm sorry, that's just the image that was brought up first. This has a interactive Excel spreadsheet for you to be able to play through a couple of different options. And there's both a PC version and a Mac version of those tools for you to download and make adjustments to assumptions and see how the replacement rates are affected. The last item is a web tool that shows how Social Security finances would change given a couple of different policy options. So you can select, say, changing a payroll tax rate, and the figures will adjust for you. And you can also then export your custom data files and download them and do further analyses if you're interested in it. So those are the 3 things that were recently released, and I just want to add that CBO is continually seeking feedback on its work to make it better and more useful. So if you have any feedback, please let me know. I'll be around after Jason's presentation, and I look forward to talking to you then. Thanks.
All right, and next we have Weifeng to talk about the Policy Change Index.
Thank you. And it's great to be back to AEI and back to the PSL meetups. So I have two quick updates. Let me see which. How can I turn to the next page, Jason? Oh, okay. It's already open. Okay, so we rolled out this policy change index project last October, and roughly a quarter ago, I gave a update about the index for China when we had an uptake on the index. So, and now a quarter later, now we are ready to give another update because we have a new data point, the first quarter of 2019. So if for those of you who are here, you may remember last quarter, I was talking about an uptick in Q1 of 2018, where after studying the articles, we found out that it's actually indicating that China is not likely to back down on the demands the U.S. is making on the trade negotiations, such as abandoning industrial policies. And in the Q1 2019, we had another uptake, which after examining the articles, we found out that's again suggesting more and more emphasis put on industrial policies like subsidizing agriculture, also using government policies more generally to solve economic problems instead of building a competitive market. And so these would suggest, put together, that although US and China are still talking and negotiating on a trade deal, it's highly unlikely that China would make a credible commitment of abandoning industrial policies. So this is the latest in the index. And for those of you who are not familiar of how this tool works, basically we have a machine learning algorithm that try to quote unquote read the propaganda newspaper of the Chinese government, and then from how they change their tone in the content to try to predict what policies they will implement in the past. And so if you look at the past jumps here, typically what happens is that after the index spiked up, we'll see an actual policy change. Of course, going forward, for example, when you see these kind of changes without actual literature, academic literature to corroborate, you won't know exactly what the change will be about, right? So it is at that point that you need to dig in and see what is causing the index to jump and what likely policies will take place later on. So and the whole project is completely open source. So if you're interested, you can dig in, look at our code, and if you have data, you can play around. We are also working toward compliance and eventually be cataloged under the policy simulation library. We have included unit tests, and we have a 93% of code coverage now. And I thought it would be interesting to mention that unit testing in machine learning is kind of different from what we normally do for unit testing. Because, so first of all, we have two challenges for this project to have very good unit testing. The first is because of copyright issues, we cannot release the raw data, which is basically every single word ever published by the Chinese official newspaper since 1946. So we can't give you guys that. And so that makes the testing a little bit more challenging. But the other aspect is that very often in machine learning models, when you have code that builds layers of neural network structures, and you say you are using this to classify documents, it's very hard to debug if you have made mistakes in the code, because sometimes you won't have any warning messages. The code works perfectly fine, but it turns out that you may not be doing exactly what you're doing. And so to solve this problem, we actually created hypothetical data. We basically it's a Chinese newspaper, so we basically use some Chinese characters, randomly draw some words to put together fake articles, so it's real fake news here. And then we manufacture some structural differences in the content. And so we throw this hypothetical data into the program, and then we show you that we actually predicted the change that we manufactured in the first place. So we are doing the unit testing from top to the end to show you that this is actually work. And so if you're interested in playing that around, we have everything open, put out on the GitHub repository. Let me see if I can. Apologies for the slow. How do I use the browser? I'm very new to Mac, as you can see. Here. No, wait. Oh, here. Okay, Safari. Okay, excellent. So, okay, you know what? I'm gonna suggest and encourage you guys to go on the website and check out how to, because I don't know how to work this out. But basically, when you go to our repository, you'll see that we have a test folder in which we have code to generate fake articles using Chinese characters. And we basically assign page numbers in a certain way within one time period, and then we assign page number in a different way after that period. And so when you throw the entire data set in, the PCI program would pick up exactly the point at the point of time when you switch the way you assign page numbers differently. So that's how we replicate fake news and how we pick out the fake policy change. Thank you very much, and you're welcome to check out our repository and send us any questions you may have.
Okay, thank you, Kevin Weifeng, again for the updates. And now we have our main presentation. We have Jason DeBacker to talk about the cost of capital calculator. So he's an assistant professor in the Department of Economics at the Darla Moore School of Business at the University of South Carolina. His research interests are in public finance and macroeconomics, and he's published papers on these topics in the Journal of Financial Economics, Journal of Law and Economics, Journal of Public Economics, the Brookings Papers on Economic Activities, and a number of other outlets. He's also previously served as a financial economist in the Department of Treasury, and he's a fellow Longhorn, having earned his PhD at the University of Texas at Austin. So, Jason, the floor is yours.
Okay, this is my machine, so it's a home field advantage for me here. Let's see if I can make it work, though. All right, so I'm here to share a project I've been working on for some time now called the Cost of Capital Calculator. It's an open source model to compute the cost of capital and effective tax rates on new investments. So Anderson gave a background on me, and I appreciate that. In addition to my day job at the University of South Carolina, I am a core maintainer of 3 different open source projects in the PSL ecosystem. I'll talk about Cost of Capital Calculator today. My colleague Rick Evans talked about OGUSA at this venue a couple months ago. And then there's a more recent project I've been working on, an open source CGE model, a computational general equilibrium model that is still in the PSL incubating stage. But each of those have repositories, and if you're interested in any of those types of models, I encourage you to go check them out on the PSL Models GitHub repo. Today, though, I'm going to focus on this cost of capital calculator. So I'm going to start with just what is it, give you a brief overview of the methodology behind this calculator. Then I'll do a demonstration of how to use it, and then I'll talk further about how you might download and use this model yourselves, and then I'll provide some kind of future direction, some things that we're trying to work on to expand the capabilities of the model. Okay, so first of all, I should say that this isn't the first open source model to compute effective tax rates on new investments. Kevin gave some really interesting updates about CBO's recent efforts to put in the public domain some of their modeling and their methodologies. But they've been doing this for a long time. In 2006, there was a report, Paul Burnham, one of the authors here, among others, publishing a paper on their methodology to compute effective tax rates. Along with that, they published an Excel workbook that had their model within it. So they had an open source Excel model to compute effective tax rates. And this was a valuable tool for many, at least for me. And I've kind of built off that. So basically, the cost of capital calculator is going to follow the CBO methodologies to compute effective tax rates. But by doing this with kind of source code rather than an Excel workbook, I think there's a couple advantages. One is that it allows users to more easily compare alternative policy scenarios. In addition, it allows the model to interface more easily with other models. So for instance, the cost of capital calculator interfaces with a microsimulation model to compute individual income tax rates. In this case, we're interfacing with the tax calculator, another PSL cataloged model. And that's helpful in computing, for instance, marginal tax rates on pass-through income, as well as marginal tax rates on dividend, capital gains, and interest income, all of which affect marginal effective tax rates on investments. In addition, having the model structured as the way it is allows for some benefits in terms of software development. So we can do things like version control. We can do more easily unit testing. The model's a little bit more modular, so it's lowers the cost of modifying and expanding the model. Okay, so this model does relate to a couple other models in the PSL ecosystem, one of which I mentioned, the tax calculator. So that is a dependency of this cost of capital calculator. In order to get those individual income tax rates, we're using the tax calculator here. As well, the output from this model is used, although the model itself is not a dependency of these other PSL models, the output from the cost of capital calculator is used to inform, for instance, the rate of depreciation for tax purposes in the overlapping generations model, OGUSA. The data that cost of capital generates is used in the business taxation model that's used to compute corporate revenue estimates and is part of that PSL ecosystem. Okay, the fundamental structure here is we're computing a cost of capital for new investments. The framework here is a Hall-Jorgensen cost of capital, so we're thinking about marginal investments where the benefits of that investment just offset the costs. So our cost of capital here is computed with this equation, so it's specified by row. We're following the Hall-Jorgensen notation, but the things that affect this cost of capital are the firm's discount rate. So R is its nominal discount rate. Pi here is the rate of inflation. The depreciation rate factors in here. That's the economic depreciation rate delta, as well as the rate of depreciation for tax purposes Z. So we have the cost of capital being a function of some economic variables, like the nominal interest rate and the rate of inflation and the rates of depreciation, as well as some policy variables like that net present value of depreciation for tax purposes, which is parameterized here by this parameter Z. U here is the statutory marginal tax rate on investments at the business entity level, so that's another parameter of this model. K is another policy parameter, that's the rate of investment tax credits. W is the property tax rate. And so all of these different parameters and variables figure into this cost of capital calculation. The cost of capital calculator itself computes this cost of capital and then a number of other related outputs that one might be interested in. So it will compute not just the cost of capital, but the user cost of capital. If you're interested, you can see the net present value of depreciation deductions for tax purposes across these different, asset types or across different industries. It'll compute marginal effective tax rates to give you some sense of what the tax system is doing to the incentives to invest. It computes a couple versions of those marginal effective tax rates, depending what your interest is. One is to compute that at the business entity level. Another is to account for not just taxes at the business entity level, but to account for those individual income taxes. So in that way, you're getting a measure of the full burden of the tax system on new investments. The calculator also computes the average burden in computing the effective average tax rate on these investments. So this is following the Devereux and Griffith methodology to compute a forward-looking measure of effective average tax rates. And then it also computes, and this is, again, a function of some of these other variables, the tax wedge. So this is basically the difference between the pre-tax and after-tax rates of return on an investment. So there's a number of different outputs that the cost of capital calculator can generate. It does these across different assets, but you can also summarize things across all assets or across an industry or a group of assets. Like, for instance, if you were interested in what's the effective tax rate on all equipment or all structures. When it's doing that, it's computing a weighted average of the cost of capital across whatever group you're looking at. So maybe we're looking at equipment, so we're computing a weighted average of the cost of capital across all different types of assets that are in the equipment group. Okay. The data source here, what underlies these calculations is a measure of different types of assets across different industries and different tax treatment. Okay, so the main data source is we want to capture the taxes on all assets in the US economy. So kind of the underlying data is the BEA fixed asset tables. So those provide a measure of the total stock of fixed assets in the US economy. We supplement that with residential assets also from the BEA, and then BEA's measure of inventories. In addition, to get a measure of land and help attribute it across owner-occupied housing versus land that's owned by businesses in some capacity, we're using the financial accounts of the US put out by the Federal Reserve. So all of these data are gathered to compute the total amount of assets in the US economy. Depending on the source, there's varying levels of detail about how those assets are allocated across different industries. But you have a detailed measure of the type of asset and a fairly detailed measure of what industry those assets reside in. But from these tables from the BEA, we don't have a good sense of the ownership of these assets by different entities of different tax treatment. So what we do there is we help attribute these assets across entities that have different tax treatment, say a C corporation versus a partnership, by using SOI data. So we're going to use SOI data to help supplement these BEA data. Right now, the model is using data from 2013. I have a student working on a pull request that's actually been open since November to update the data for cost of capital calculator. We're still waiting on the IRS to put out the 2014 corporate data. They have 2015 data for partnerships and sole proprietorships, but the corporate data seems to be lagging behind, and we'd like to get that to update some of our data sources. These data sources, there's some judgment calls here in terms of what we're using. So we're measuring the effective tax rates on new investments, but we're using data on the stock of capital. The BEA does put out detailed measures of the amount of investment across different asset types and across industry. We've chosen to use the stock of capital just because it changes less over time, and we think represents kind of a good sense of the current mix of assets and how they're being treated under the tax system. Okay. So I've talked about how these sources interact. We're supplementing those BEA data with SOI data. The SOI data giving us things like the amount of interest paid and depreciation deductions across industry, and we're using those measures from income tax returns to help attribute these assets across different industry. Okay, so there's just some kind of apportioning of the total stock of assets from the BEA across different industries and tax treatments using the SOI data to inform where it goes across tax treatment. And then also where the BEA data may lack detail on industry, we're using the SOI data. If it has more granular industry detail, we're using that to allocate assets across more detailed industry groupings. Okay. We look deeply into what the partnerships returns are saying about the ownership of assets from corporate versus non-corporate partners, and we're helping then to allocate assets to the corporate entity form if that's the ultimate owner of the investment or asset. Okay, so the cost of capital calculators, I talked about in that calculation, the Hall-Jorgensen cost of capital. There's a number of parameters that affect the cost of capital, also a number of economic variables. Most or maybe all of these are addressable or subject to the user's control with the cost of capital calculator. So through its interaction with the tax calculator, you can adjust any parameter in the individual income tax code that the cost of capital, that the tax calculator allows you to adjust. In addition, through the cost of capital calculators API, you can adjust business entity tax rates. So the corporate income tax rate, you could put a entity level tax rate on what are now pass-through businesses. You can change a number of parameters of the depreciation system. So you could change the type of system that is used to depreciate assets from kind of a maker system to a ADS system or an economic system where you have economic depreciation for tax purposes. You can change the rate of bonus depreciation, which allows you to model full expensing of investments. And you can do this separately by the class life of assets. So you could change, say, the amount of bonus applied to 3-year property or 5-year property separately. Okay, you can adjust also the deductibility of interest. That's going to affect the cost of capital. You can, there's parameters to have an ACE system or an allowance for corporate equity system. Property tax rates, investment tax credits can all be adjusted. And then those economic parameters that factor into the cost of capital, like the inflation rate and nominal interest rates, can be adjusted. Okay. So that's a little bit of background. Now we'll do a bit of a demo here of how to work with the cost of capital calculator. All right. So I'm going to do this just in a Jupyter notebook. Looks like, is that readable to everybody? It looks like the font is big enough, but I'm glad to increase it if necessary. All right, so I started a notebook, and I'm just going to kind of work through it and explain what I'm doing and how I'm working with the model and what we're seeing here. Okay, so the first step here is I just need to import some dependencies, some libraries that the model is going to use. So there's some general Python packages you might see used in many of the PSL models. We're going to use pandas and NumPy. We're going to plot things with Bokeh. And then after those imports, we're going to import the cost of capital calculator itself. That's the import CCC line here. And then from the cost of capital calculator model, we're going to import some functions and some classes. So we're going to import, there's a class called assets, which is going to carry around the underlying data that these calculations are going to be made on. There's a class called specifications that's going to basically contain the parameters of the model and allow us to change those. And then there's a calculator class that actually does the calculations and helps us look through some of the output of these calculations. Okay. All right, and then, so I've just imported those libraries that are necessary. The next thing I'm going to do is I'm going to create an instance of this assets class. So I'm going to call a new object, creatively assets, and that's a name for an instance of this assets class. And then I'm going to just print out the first 5 lines of what this data frame looks like. So basically, this assets class carries around a data frame of really just, you can think of it as a table of these underlying data of the assets. And they're allocated by tax treatment, the type of asset. So here's the BEA asset code. There's kind of a detailed name for that asset. In addition to that description, we have it separately by industry, by industry, and then with these data we see included are the tax treatment of these assets. So what is its class life, what system is it depreciated under, what method is used, and what is the economic rate of depreciation. Okay, so that is, so this, So this data frame, so this is, I'm just printing here kind of the size of this data frame, and it's fairly, so this is, what is that, 2.8 million observations. This is all combinations of these detailed assets by industry, by tax treatment, is what kind of underlies this. Okay. All right, next what I'm going to do is I'm going to create an instance of the parameters class, the specifications class. Okay, so I'll show this in a couple ways. So one, here I quickly create an instance of this parameters class. I just called it P. And then I'm just printing here, I did P.U. So U is an attribute of this class. And here, like in that cost of capital calculation equation you saw before, U is representing the statutory marginal tax rate. There's actually 2 of those, one for corporate entities and one for non-corporate entities. And I didn't put any arguments in the specifications function, so it's just returning what current law is in the default year, which is 2019. So it's saying this year, the corporate income tax rate is 21%, and the marginal effective tax rate on non-corporate entities is about 19.5%, okay? That number is a weighted average. What it's doing, or where it's computed from, is from that tax calculator. We're computing the marginal tax rate on pass-through income for all individuals in this case, in the CPS file that's used by the tax calculator. And then we're computing a weighted average of that across all filers, and that's where you get this 19.5%. That ran really quickly because I didn't call tax calculator. I just used what the default value for those income tax rates are. So those are, if you're using kind of a current law baseline, all of the default values for these marginal tax rates from the tax calculator are already part of the baseline per default parameters for cost of capital calculator. But if you wish, say if tax calculator were updated or you want to change something, you can add an argument to the specifications class when you create an instance of it to call tax calculator. And now this is going to take a little while because it's got to go and run the tax calculator. So simulate a couple 100,000 individuals and compute their tax liability, change their income a little bit and do it again so you get these marginal tax rates. And that's the calculation that's going on there. All right, so that should be done in a few more seconds. In the meantime, I'm going down to the next cell. So we've initialized an asset, an instance of the assets class, so that contains the underlying data. We've initialized an instance of the parameters class, so now we've got some parameters. So we've got the parameters and data, And the next thing to do is just do some calculations with those parameters and data. So I can do that. I can start that process off by creating an instance of this calculator class. So I'm going to call it calc1. And it's going to call this calculator class, giving it the parameters I just specified. I called those P, and the assets that I just initialized called assets. So I'm passing that to the calculator object. And that's going to run, that's going to compute kind of the baseline calculations of this model. And what we're going to see is that those calculations are going to, so I'm not going to see anything there. I'm just going to have this new object called calc1. That is a calculator class object for the cost of capital calculator. And I'm not really going to see anything to begin with. So if I want to start to see some of what's been computed, I can look into or use some methods of this calculator class. So in this next line that I'm on, I'm looking at this method called asset share table. And what that's going to do, that's going to give me just a summary of how these assets are apportioned across industry and across tax treatment. So it's just printing out a table here. You could save it to a file here. I just have it being printed in the window here in our Jupyter notebook. But that's just showing the share of assets across industry, the share that go to the corporate form, and the share that are attributed to the pass-through entity. So for instance, in the ag sector, we're attributing about 31% of assets to corporate entities and 69% to non-corporate entities. Okay, so that's interesting. But maybe what we want to do is we want to compare different policies. So we want to change something in tax law and then compare how our effective tax rates change or how our cost of capital changes. All right, so to do that, we just want to specify a new or a different policy or set of parameters. So we're going to create another instance of this specifications class. I called the first one P. I'm going to just call this P2. And I'm not very creative here. I'm finishing my classes up, and I didn't think too much about this. So what I'm going to do is I'm just going to change what year we're going to look at. So one thing we know is current law is going to be changing pretty significantly after 2025. So let's just look at how things are going to be different comparing 2019 to 2026. Okay, so I'm going to, in this specifications class, the new one, we're going to just set the base year to 2026. So we're going to get the policy parameters from year 2026. And then let's also suppose that the corporate income tax rate goes up. So I'm going to create this new instance of the specifications class of the parameters. And then I'm going to get all the defaults for 2026. And then I'm going to, on top of that, I'm going to update the corporate income tax rate to be 25%. Okay? So I'm going to do that and then create a new calculator class with those new parameters. Okay? The distribution of assets here is the same, so we're passing that same assets object. Okay? All right, so it's just giving me some feedback. Okay, you updated this parameter, the corporate income tax rate, to 25%. Okay, so now we are interested in, we've got two policies. We've got 2019 law, and we've got what's going to happen in 2026, plus increase the corporate income tax rate from 21 to 25%. Okay? So what happens? So we can look at a summary of what happens. We can use this summary table method in the calculator class. So what I'm doing here, I'm calling this method summary table, and I'm passing it calc2. So it's going to basically say, okay, you have one calculator that's doing stuff for 2019, another that's doing stuff with kind of 2026 law. Let's look at those both and compare them. And so it's returning here this table that's telling me the marginal effective tax rates under baseline, which in this case was 2019, the reform, which in this case is 2026, plus the increase in the corporate income tax rate, and then the difference between the two. So it's giving me the summary table for across all investments, that's the first line overall. For all corporate investments, that's the second line. For corporate investments that are equity financed, debt financed, pass-through investments, and then those pass-through investments, whether they're equity or debt financed. Okay? So as expected, the law is going to change. Individual income tax rates are going to go up. The qualified business income deduction will go away. We will no longer have full expensing. So we're going to see marginal effective tax rates increase, and generally we do. The difference here is with debt finance investments, because debt finance investments, you're deducting things at that higher tax rate, those actually end up going down. But we have a nice summary table of what happened comparing between these two reforms, okay? So the kind of default output here is to tell you what happened to the marginal effective tax rate. If we wanted to look at a similar table, but look at what happened with the cost of capital, there's an argument for that. We can change the output variable we're looking at. So here I'm going to pass an argument saying output variable equals rho, or the cost of capital. And then I can get a sense of how the cost of capital changed across these groups between the baseline and reform. Okay. If we want to, we can save these results to disk. So I've just had them print out into the Jupyter Notebook, but we can print these to disk. Let me see where I have my, I saved them as an Excel file, so we could open that up. And it might open up. Excel's pretty slow, but. So we have kind of a nicely formatted table to show us these differences across all investments, corporate versus non-corporate, debt versus equity finance. Okay. All right. Okay, so we got that overall summary, and then there's a number of other methods to help you visualize or view through a table format the output of this model. So we did a summary table overall. We can do a summary table by asset. So we can look across different types of asset. How have these marginal effective tax rates, or how's the cost of capital changed between the baseline and reform? Okay, so here it's giving kind of overall for corporate investments, for corporate equipment, corporate structures, and so on, for all pass-through, for pass-through equipment, pass-through structures, and so on. If you're interested in kind of the impact across different industries, there's a summary table that can be built to do that as well, where we're looking here across kind of two-digit NAICS codes between corporate and non-corporate and the change in marginal effective tax rates. You could specify here as well the output variable, look at changes in the cost of capital or the user cost of capital, and so on. And then there's some visualization. So if we were, say, interested in kind of visualizing what is the effect across different types of assets of this change, we could view that as as a bar graph. So here's a method called grouped bar. This is going to produce a bar graph looking at the differences between the baseline and reform policies across different asset types. So here we're plotting it for corporate investments, the marginal effective tax rate, and how it's changed between the baseline and reform. And so here, for instance, we can see that for equipment, it's a big change in 2026 because we're from now to then, right? Because we're losing full expensing. For things like structures, it's less of a big deal because we're not expensing those under current law. Okay. We can do a bar plot, a group bar plot like that, where we do things if we were interested in the impact across industry. So we could call the same grouped bar method of the class, but just pass it group by asset false, and instead it will group by industry. See if I can get this all on one screen. So it's a bit taller, so we can fit the industry names. But you can see, again, differences in how the policy or the change in policy that's coming down the pike is going to affect investments across different industries. A lot of this has to do with, of course, the composition of assets across industries, but nonetheless, you might want just a summary to think about, okay, well, how is manufacturing going to fare relative to retail in 2026 and the changes that are looming. Okay. We have some other plots that show things like, again, just to help summarize kind of the variation in the tax treatment of different types of assets. So there's a method called range plot that you can then compute the range of, say, in this case, we're plotting the range of marginal effective tax rates. Here it's for corporate investment. So what this is showing is basically how differently does the tax system treat different types of assets. So these range plots are showing the max marginal effective tax rate, the min marginal effective tax rate, and then the average marginal effective tax rate for typically financed, so a mix of debt and equity finance investment, debt finance and equity finance investments. And so you can see the ranges between the baseline and the reform. And so you can see, for instance, like those ranges are stretching out a bit in 2026, meaning that there's going to be kind of less equal treatment of different types of assets in 2026 than there is in law in 2019. Okay, so that's a helpful visual for kind of thinking about how the tax system is differentially treating different types of assets. And so there's options on this range plot where we could do a range plot and plot for, we plotted for corporate, here we'll plot for pass-through investments, so we can see the range of these marginal effective tax rates on pass-through investments as well. So there's a lot of options with respect to these plots where you can do corporate, non-corporate. You can include or exclude certain types of assets. You can group by industry or asset and things like that. And then one other visual I'll show you is just another way to kind of visualize the differential tax treatment across different types of assets, and that's through kind of a bubble plot visualization. So the size of the bubble here is giving you the amount of assets in that category. So here, these are corporate investments for different types of different types of structure investments, and we're seeing the range of marginal effective tax rates across those different structures. So those are some of the things that are kind of built into the capability of the cost of capital calculator. And you can run it as I did here with interacting with Python. Here I'm using Jupyter Notebook to do that. You could do that in other ways, but you could kind of play with this model in that way. I'm going to meet this afternoon with Hank, and we're going to work on trying to get this on the comp platform. But there is a no longer kind of maintained web app where one could run this. And we're hoping to get something like this with the more updated version of the cost of capital calculator. So this web app that was supported by OSPC was a way to run cost of calculator without having to know how to code in Python. And we could go here and change some of these policy parameters. And then we can say, show me the results, and it's going to run. Just like tax calculator runs on TaxBrain, cost of capital calculator has a web application where you could run these reforms as well. This is going to take a little while because we've got to run tax calculator. That's what's going on behind the scenes here. I thought I hit run. Okay, here we go. So this is going to take a little while to show us some results. I'll come back to that, but let me show you some other ways in which we've used cost of capital calculator to kind of visualize some reforms. So there's these aren't direct outputs of the cost of capital calculator model, but they're using the output of the model to make some informative kind of widgets to think through what's happening with tax policy. So one we had done in the past, this is before the TCJA, when bonus depreciation was phasing out. Under current law, we just made a visualization to think about what are the implications of bonus depreciation phasing out as you kind of move through the budget window. So you could see those marginal effective tax rates changing as bonus depreciation phases out, and how they might differentially affect different types of assets. For instance, what you're seeing is the structures, those long life structures that weren't getting the bonus depreciation, right, they're remaining fixed. So that was kind of a neat tool to think through what was going on and the effects of bonus depreciation phasing out over time. Around the time of TCJA, we had put out another widget that would help people who, again, don't want to code think about what the effects of different options for tax reform might do to investment incentives. So we created this widget with basically we ran the cost of capital calculator a bunch of different times for different corporate income tax rates, different depreciation systems, different level amounts of interest deductibility, and then somebody could come and play with this widget and just think through, okay, what if we changed the corporate rate to 20% and we gave full expensing, and we made interest not deductible. And we could see the reform here being the red circles or red lines, and the baseline being the blue. So we could see kind of what would tax reform do to these different investment incentives. Okay. All right, so let's see if we can go back to, so our cost of capital calculator run has finished, and at the top of this output screen, it shows a bubble plot like I showed you in that Jupyter Notebook. This one is a little more fun because it's got these buttons here, and we can look at different output options. So there's a lot here in this picture. Seems like it may not be updating with our reform. But you can, okay, here we go. So it's now it's responding. So we can look at different output variables, marginal effective tax rates, the cost of capital, the net present value of depreciation deductions. We can look at how those things change between what they look like under the baseline or reform, or the difference between the two, how they vary if they're debt versus equity finance, and so on. So kind of a nice visualization. Again, this is out of date, but I hope to have something up working soon on the comp platform where users can go and have a web application where they can interact with the cost of capital calculator to just lower the barrier to using this type of model. So in addition to that, this would print out a table like we were seeing in that Jupyter Notebook with summaries of the measures of marginal effective tax rates across industry and tax treatment. Okay. All right. Okay, so I showed you some of those widgets. Yeah, so that is the cost of capital calculator. And what I want to do and why I'm here is I want to get people interested in it. I want people to use it. I want people to contribute to it. And the way to do that is to go to the GitHub repo for cost of capital calculator. You can leave thoughts there. There is a button here for issues. Some of you have told me about issues before, and they may be reflected here. Either you posted them or I posted them on your behalf. But that's a good place to leave feedback for the model, for things you'd like to see, questions you have about how to use it. This repo is also the place to go to use this model if you're interested. To do that, you could click clone or download, and you could just download a zip file, or you could get this URL to clone it. This is going to be risky. I don't know how the Wi-Fi is working as I do this Zoom meeting, but we could try to just do a demo here of how one might do this. So what I'm going to do is, let's see if we'll see how quickly it downloads. If it seems like it'll be a while, I will stop. But to do this, what we want to do is, let me, yeah. So I'm just going to take that, I copied that URL, and I'm going to just do a git clone. And I'm going to clone this cost of capital calculator repo. Looks like it's downloading pretty fast. So now it's just downloading all the files that reside in this repository. There's a bunch just to kind of create packages and things. Most of the ones that do the calculations are in this CCC folder. And you can see that calculator.py, that's where that calculator class is defined. There's data.py, that's where the assets class is defined. Parameters.py, that's where that specifications class is defined. So those different objects you've seen, they're kind of related in these different modules there. All right, so we've cloned that repo. So now I can see that there's a folder called cost of capital calculator. I can navigate into that folder. There are some files there. Kind of important is, one, we need to make sure we have all the necessary software infrastructure to run this. So what I'm going to do is I'm going to create an environment. Actually, I already have this environment on my computer, so I'll just do source activate CCC dev, which is the environment for the cost of capital calculator. So now I'm in a virtual environment in Python that has everything I need to run the cost of capital calculator. It doesn't yet have the cost of capital calculator, so I'm going to build that package. Okay, so I'm doing a command here. All of these instructions that I'm doing right here are relayed in the cost of capital calculator repo on the main README page. So I'm just following these. I've already have Anaconda on my computer. I already created the environment on my computer, so I did the source activate CCC dev. I installed the cost of capital. And then for people who want to just work with this and don't know much about Python, we've put in this repository an example script that you could run. So I'll run that. So it's in this folder called run examples. And in that folder is, I guess there's 6 CSV files. So these are examples of the output you should expect if you run this example file. And then there's a .py file that is the script we would want to execute. So I'll do Python run CCC example .py. And that's going to run this cost of capital calculator. So it's going to look at a baseline policy, some reform, and then do some comparison of the two. So this reform is, we can see here what's being changed. So it's changing the corporate income tax rate from current law to 35%. It's reducing the amount of bonus depreciation on assets with lives 3 to 20 years from 100% to 50%. Creates one of these bokeh plots that pops up in my web browser. It also would have generated some CSV files. So we have those ones we expect, and then there's some new CSV files that have or lack the expected suffix that are what are created, and you could check with some kind of diff utility whether those match what they ought to match, and they should. And so that's a way to run the model. And besides running it, it kind of just gives an example if somebody wanted to work with the model. Oops, I don't have that open. Let me open it in the web browser. So it gives me, or it gives you, any potential user, an example of what a script might look like if you wanted to create your own version to run the model. So it's got kind of an example of, for instance, things we did in that Jupyter notebook, how to initialize a parameters class, how to update some reform parameters, so adjustments to business income tax parameters, for instance, okay? And then how to call those calculations and actually do the calculations that underlie this model, okay? So that example script is in that repository, and in the README for the repository are the directions to kind of work with that script or get it running. Okay. All right, so that's what we have. What we want to do is kind of add some other features. So we have some calculations for the effective tax rates and cost of capital on owner-occupied housing that's computed. We'd like to think about how best to kind of relay this in some of those output tables or figures. Of course, I'm waiting with bated breath for new data from the IRS, so we'd like to update those data to something more recent. Some outstanding issues that we'd like to work on is how is, like, for instance, the R&E credit, how should we handle that here? Another thing is right now we have partial interest deductibility, and that interest deductibility depends upon the amount of interest relative to some measure of income, and that kind of relies on microdata. So there's a question of how do we include the effects of that in this model that uses kind of aggregates across, say, an industry group. So those are some outstanding issues, and we'd love kind of any feedback you have about whether those or other issues are important or how maybe best to address these. All right, so thank you guys so much for listening to this. I hope you have some interest in the model. I hope you want to contribute or at least offer some suggestions about how this model should be shaped going forward. And I'm here to take any of those right now if you have them.
So if I want to aggregate those NAICS codes, is that something that cost of capital calculator does automatically, or do I have to go into the code and write my own kind of industry aggregation of those METRs?
If you wanted to aggregate at different levels?
Yeah, so if I have a model that doesn't have 2-digit disaggregation of industries, but I have like 7 or 6, so I've aggregated them according to my own recipe.
Okay.
Is that something I have to go in and code myself?
So currently you could get 6-digit or 2-digit NAICS codes, but yeah, if you wanted some different level of aggregation, that would need to be an adjustment to the model.
Okay.
It's a good question. That would be a good feature, I think, to have, is to allow that level of aggregation to vary.
Thanks. Maybe a little off topic, but if you have that granular output for industries, have you looked at whether or not it predicts investment or changes in investment rates or anything?
We haven't done that kind of back testing of prediction. So, this just computes effective tax rates. I mean, the kind of behavior, like how firms respond to these changes, is something beyond the model. We have kind of used the model to inform such type of analysis. So for instance, if you compute the cost of capital, there's a literature estimating, say, the elasticity of investment with respect to the cost of capital. So you can use this output and some measure of the elasticity like that to get a sense of the response. I've done that in aggregate. I have not done that across industry. That'd be interesting, yeah.
You've certainly shown that if you make different assumptions for various your parameters, you can get different ranges. What happens when your parameters, what can you do, how do you handle situations where your parameters are not well defined or have uncertainties? For example, interest rates, depreciation, or the basic data set of asset classes is uncertain to a couple % each. Does one have to basically run a separate model for each time, or do you have a nice way of generating overall uncertainty?
Yeah, so you would need, that's a great question. We're in another venue talking about that this morning. And so it's a really interesting thing to think about how you can use these models to, say, define confidence intervals over your estimates. And that is not built into this model, but you could envision how we did this, initializing a parameters class, running the model, right? You could envision, say, writing a loop over that call, where you, in those loops, you're varying, say, you're drawing some interest rates from some distribution of potential interest rates, and in that way you could compute kind of the confidence intervals of these calculations with respect to uncertainty in the interest rate. And of course, you could do that over a number of parameters. But so, the model is well suited because it's quite easy to kind of initialize a parameters class and run the model separately to do that. It's not a push button thing, but with just a few lines of code, we could get that done. Yeah.
In regards to the IRS data from 2013, what would you say would be the margin of error trying to compare that to these updated numbers? And do you know why the numbers are as far back as 2013?
So we could get data before 2013. I don't know. So we've kind of updated the model with some new data. It's not in the current package, but in kind of this branch that a student of mine is working on with the proprietorship and partnership data, we've updated those numbers. I haven't seen what the differences are. I just kind of want to get further away from the Great Recession and into kind of a more recent kind of policy environment. But again, we're using these fixed asset tables, so it's not like investment numbers that are changing a lot year to year. So I don't think it's going to change too much, the underlying data, but I think it's important to kind of try to update those. And where the major changes are coming from, of course, are not from those fixed assets, but from the SOI data itself. It kind of, as you're suggesting, there the income tax data, things are changing more quickly, and so that may have a larger effect. But I haven't looked into what those differences are with the non-corporate entities, although we do have those data.
You may have talked about this, but you talked about allocating assets between corporations and non-corporate businesses, but you didn't mention S corporations, which BEA data is famous for aggregating C and S's together. Yes. How do you deal with that through SOI as well?
Yeah, exactly. Yeah, so that the BEA aggregates all corporate entities, which are not all treated like corporations for tax purposes. We are using the SOI data to separate out S corporations. That's right. Yeah. All right, well, thank you all so much for your questions. I appreciate it.
All right, well, that does it for our meetup for this month. Thank you, Jason, for coming out to talk. It was a great presentation. And thanks to all of y'all for coming out today. If you want to hang out for a bit, we'll be sort of hanging around in this room. There'll be some stacks in the back if you want to talk to Jason or some of the updates they've had earlier. And if you haven't, sign up for our email list, and so you can be updated when we have our next meetup, which will be sometime in May. Thank you for coming out, and hope to see you again next time.